In this video, we will introduce linear groups. So we have two groups, GLNR and GLNC. And a linear group is a subgroup of either of these, GLNR or GLNC, for some n. And this is just a group, it's the abstract group, as in not a topological group or anything. This is just a plain group. So here are some examples. Well, certainly GLNR and GLNC are linear groups. We can also view Rn as a linear group. So maybe I should be more precise and say that it's really a group that is isomorphic to a subgroup of either GLNR or GLNC. So one way to do this is, suppose that you have x1 through xn. So with this n tuple, you can pair it with the matrix whose diagonal entries are e to the xi. So this would be an element of GLNR. So this embeds Rn. It gives an injective homomorphism from Rn into GLNR. Okay, it's easy to see that this is a homomorphism, right? Because E has the exponential property. Okay, so this is one way to do it. Another way to view Rn as a subgroup of GLNR is to embed it this way. This is another homomorphism. You take your tuple x1 to xn and then assign to it the matrix. This is in GLN plus 1, which is the identity matrix for the n by n part on the top left, and then it's zeros here, and then it's x1 to xn here, and then 1 here. And you can see that this is a group homomorphism. Okay, another example is to take the circle group S1. So this is the subgroup of C consisting of all complex numbers such that the modulus of Z is 1. And this is isomorphic to a subgroup of GL2R. So what you can do is you can take each element in the circle as e to the ix, and then you pair it up with the matrix cosine x, sine x, negative sine x, cosine x. This is in GL2R. And when you have two linear groups, you can take the product. So if G1 and G2 are linear groups of, just subgroups of, say, GLMR and GLNR, then we can view G1 cross G2, the direct product, as a block diagonal subgroup of GL M plus NR by putting G1 on the top left and then G2 on the bottom right and then 0, 0 everywhere else. So that's what linear groups are. Of course, in a different context, you might hear linear groups defined differently, but the way I mean it is this definition.